call for the people to come in because I told Thursday to come in, but then I was like, oh, there I'm live. Hey, I'm live for the 3 people that are hopefully going to go up to a lot more people, but we'll figure that out. Anywho, here are my goals for today. Number 1, I would like to review the questions that I assigned you out of the textbook. As always, when I assign you something out of the textbook, this is merely like a practice type thing. This is for you, really, to get this thing done, completion grade, but obviously it has to be by completion, of course, and on time. But I would like to review those questions and take any questions that you have in regards to that. So if you're in the chat, of course, you can ask those questions when I review various problems, or if you want me to jump to a certain problem. I may not get to all of them. It was like 6, 10, 11, 15, 24, and then I put a star next to 28. I put a star next to 28 because that was something that we hadn't spent enough time on. So I think, how did I word that? I said I would be like, I wouldn't mind it if you like bombed it or something like that. Yeah. So again, number 28, just as long as you, oh wow, I went down to 1 person. Where did everyone else go? Now I'm sad. Okay. Afterwards, I would like to get back into the death charts of the Titanic, just to kind of wrap that up a little bit. And then I want to do a little intro to another thing that's coming up called the normal distribution. One of the things that I think I'm going to give you besides the assignment is a video to watch at some point, but I haven't decided which video. I'm debating between like 2 or 3, but I want to talk about something that's very important called the normal distribution, which is going to be the cornerstone of a lot of things that we do in AP statistics. Anyway, I'm so excited. All right. Now, I put it on number 6 just because it was that first problem, but actually I do just want to start with number 6. Like I said, I may not have time to go over every single problem. I would like to go over number 6. I would definitely like to go over number 28. And then I would like to take whatever questions you guys have. So, number 6. Clarksburg Bread is trying to predict how many loaves its bakers need to bake. In the last 100 days, they've sold between 95 and 140 loaves per day. At the top of the next column is a histogram of the number of loaves they sold for the last 100 days. And thus, I got to move my screen over. Come on, screen. Oh, you're just not going to cooperate with me now, are you? Come on. What the heck? I hate things. I hate things and how they don't work. What just happened? Page 136. There we go. There's the histogram. I'm going to leave it there for a moment because I don't want to mess things up. But there's the histogram. Now, a couple things about that histogram before I even read the questions. I'm looking at that histogram. Clearly, there's a peak all the way to the left. There seems to be a trailing feature all the way over here. 95 is the minimum. 145 is the maximum number of days. I'm just keeping an eye on things. The one thing that I would look at this textbook and I'd say, nope, I'm going to take points off. I would have preferred a little bit of a title, but again, that's on the textbook. I would have preferred a title because if I'm looking at this chart, I need to know what I'm looking at. Now, yes, the paragraph described it. I'd still like a title. Anyway, part A. Part A asks for you to describe the distribution. What 4-letter word did I tell you to not say, but say to describe a distribution? There you go. Yeah, you're not supposed to cuss. Shut up. Anyway, center, unusual features, shape, and spread. Now, it says to describe the distribution. Center, well, which center do we use? In this case, are we going to use mean? Or are we going to use median? What are we going to use? Ooh, it depends on the shape. What's the shape? Ooh, what shape would this graph take? Definitely skewed right. Definitely skewed right. Definitely skewed right. You look where the tail is. You look where the average is being pulled up. It's being pulled up by these numbers over here by the end. I would definitely say the shape is skewed right. Now, again, center, I would definitely describe the median. How many loaves of bread did they say they had? So it was between 95 and 145, and this is the number of days. So it was the last 100 days. Okay. Oh, sweet. I could easily describe the median. If this histogram is representing 100 days, and this is just below 50, that means the median has to be in this right here. And again, I would roughly estimate, what is this going up by? going up by fives. 105, 110, 115, 120. Yeah, it is going up by fives. Look at me. Cool. So if this is 95 to 100, I would say that the median or the center of this data is between 100 and 105. Yeah. Unusual features? Nah. I no, it doesn't have any outliers. I can't say. It doesn't have any gaps. I mean, you might say like, 145 is clearly an outlier. I know, but they have a couple of them up here as well. I can't really definitively say whether or not there are any outliers unless I did that calculation for outliers. So if I can't definitively say it, I'm not gonna. There are no gaps and there are no multiple peaks, so skip that. Shape, we just said it was skewed right. Spread. Because it is skewed to the right, I'm going to have to talk about spread in terms of IQR, interquartile range. Interquartile range would be Q3 minus Q1. I would have to find roughly the 25th percentile and the 75th percentile. Now, the 25th percentile is most definitely between, I'm going to write this, 95 and 100. It's definitely in that range, the 25th percentile, because there's 100 data points. Q1 should definitely be in that data range. Q3 should be in the 75th percentile. Let's just see, that's just under 50. And I'm going to estimate that at like, I have no idea, so I'm going to say like 48. I'm going to say that's roughly 25. Yeah, so Q3 should be in here then, because then that would just be under 75, and then that would be 75 right there. This is all estimation at this point. They're asking you to describe the distribution without knowing a lot about it, without knowing the individual data points. So you just have to estimate approximately where these data points would be. So if Q3 is between 95 to 100, I'm sorry, Q1, and Q3 is 105 to 110, that means that the IQR should be 10. Yeah, it should be approximately 10. I wouldn't say that it's exactly 10 because I don't know for certain, because I don't know the individual data points, but we'll kind of go with that. Approximately 10. Fluffy language. Part B. What would be larger, the mean or the median? Well, just very quickly, we can all say it in a group and all high five each other. Is it the mean or the median? Yay, we all said it together, except we didn't. Yay, it's the mean. The mean is definitely larger. Why? If you had to put it into words, why? What did Derek do to the average height of my friends? Pull that average up. Because it is skewed to the right, those larger data points are pulling the average farther to the right. There, that's just basically what it comes down to. Remember, I did not have you do part D. I hope you didn't try part D, because I specifically said don't do D. But I did have you do C. Here, oh, look at that. Dude, I didn't even look at that. This is what happens when you don't read the problem. Look, they gave you the IQR technically. You can do it with the summary statistics. I didn't even think about that. Here are the summary statistics for Clarkberg's bakery bread sales. Use the statistics and the histogram above to create a box plot. You may approximate the values of any outliers. Sweet. So we can do that. Nice. That's cool though. I was pretty close, like 95 to 100 and then 105 to 110. I was pretty darn close. That's why I said approximately 10. But now I can get the actual number, but that's besides the point. Let's see here. I'm going to do a box and whisker plot. I'm literally going to put it up here. So this is, I'm going to put it up here. There's 100 for the median, 95 for the minimum, 97 for Q3, 105.5, so it's like roughly right here for Q3, and then 140 for the maximum, which would put me about right there. There's my box and whisker plot. Looks pretty good. I tried to match it to the x-axis scale on the bottom. If you're going to be drawing this thing freehand, obviously you would create your own x-axis and you would put the hashtags in for hashtags, whatever. What do they call those exactly? Whatever they call those. You put those markings in. Cool. But then it says you may approximate the values of any outliers. I'm going to do better than that. I'm going to go beyond that. Instead of approximating the value of any outliers, I'm going to do this, but I'm going to do it with the actual numbers. I would prefer doing it this way. If any number, that's a 1, is outside this range, it's an outlier. But Mr. Markey, you don't know any individual data points. I know, I don't know any individual data points. I don't know. But let's just see what happens. What is my IQR here? My actual IQR. I know I approximated 10, but what is my actual? What is that? 8.5? Someone confirm me? Cool. I'm hoping. I don't know. It's early. Now, I don't have a calculator, and a couple of you do have Chromebooks open, so please, by all means, you have a calculator. I don't on me at the moment. But let's see. 97. I don't know why I put a dash there. 97 minus 1.5 times 8.5. Somebody do that. And comma. 105.5 plus 1.5 times 8.5. I need to know what that range is. And again, my calculator's all the way over there, and I can't reach it. I got short arms. And I'm walking away from it, too. Someone confirm it for me? All you with Chromebooks are like, crap, why did I open it? For the second one. 118.25 for the second one. Okay. 118.25 for the second one. What about the first one? 84.25. Okay. 84.25. Okay, now that's the range. The question says you may approximate the values of any outliers. I don't know the individual data points, but I know for a fact, and listen to this phrasing very carefully, I know for a fact that there is at least one outlier. I know for a fact that there's at least one. The reason why that I know that there's at least one is because of the minimum and the maximum. The minimum is at 95, which is within that range. The maximum is at 140, which is outside that range. I don't know how many numbers would be considered outliers. I don't know how many, but there is at least one on the upper end. If that also happened for the minimum, I would say that there are at least two, but I can't say that. The best I can say is there's at least one, and it's because of that the maximum lies outside that range. Don't say that there is one, at least. Fluffy language, because you can't prove it. They don't give you the individual data points. I love it. Fun. Now, obviously, there's number 6. I just talked about. There's 10, 11, 15, 24. And I'm definitely going to go over number 28 eventually. But I wanted to give you an opportunity. Which one of those questions would you definitely say, please, 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 help me, please? I need to see that problem. And you in the chat, too. You could answer, too. Yay. Although I probably should stay over here in case they're going to type into the chat for a moment at least. Let me scroll through a little. So it was 10, 11, 15. Let me look at those real quick. Again, I'm not going to go over every single thing in this thing. Boop. There's 10. Got it. And there's 11. Love it. Nice. Create the graphical display. Maybe I'll create the graphical display for that. So it was 10, 11, and what were the other numbers? 15, 24. Okay, 15. There's 15. Nice. And then Come on, 24. There you are, 24. Fantastic. Excellent. And then I'm taking a peek at 28. Oh, yeah, 28. We'll definitely talk about number 28. All right, let me, if no one has a suggestion. Oh, good. Literally, I was just going to 11. That's perfect. Okay. All right, we'll do 11. Let me erase that junk on the board. Cool. One Thursday, researchers gave students enrolled in a section of basic Spanish a set of 50 new vocabulary words to memorize. On Friday, the students took a vocabulary test. When they returned to class the following Monday, they were retested without advance warning. Both sets of test scores for the 25 students are shown below. So there's the Friday and there's the Monday, the pre-test and the post-test. And then they're in double columns. So, okay. Create a graphical display to compare the two distributions of scores. Write a few sentences. Oh, hold on. Let me do that first. I can't write a few sentences until I know what the graphical display is. So what I'm going to do, I'm going to have to enter these into my calculator. Here we go. Let's see. 42, 44, 45, 48, 44, 43, boom, 41, 35, 43, 48, 43, 45, 47, 50, 34, 38, 43, 39, 46, 37, 40, 41, 48, 37, 36, boom. Oh, I totally mistyped that number. You can't see what I'm typing right now, but it is bad. How did that number get there? 36, where's 36? 39, 46, 37. And then 40, 41. Okay, so insert 37, 46, hike. There we go. So let's just take a look at Friday first. I'll put in Monday in a moment, but let's just take a look. Boom. At Friday first. Here is the Friday numbers. Focus. There we go. Second, y equals. Enter on the plot. Turn it on. Let's take a look at a histogram. Zoom 9 that sucker. Oh, nice. Okay. So what did it say exactly? It said to, now I know I still have to do Monday. I'll do that in a moment. But it says to write a few sentences about the scores reported on Friday and Monday. Oh, then it says to create a graphical display. Nice. And then describe the distribution of changes. Okay. Interesting. So we talk about Friday scores. If you wanted to write a few sentences that were not a graphical display, I would need some information. And if you hit stat and you tab over to calc and do one var stat, I believe it should spit out some numbers for you, which is nice. I really hope I typed in the numbers correctly. I was typing them very fast. But if my numbers are correct, then I would assume X bar, let me point with a pen, here we go. X bar, which is your mean, and S, which is your standard deviation. Those are the two numbers from the top of this chart that would be helpful to you. And then if you scrolled down, this 5-number summary would also be helpful to you. And again, I really hope I typed them in correctly because I was typing them in fast. On your guys' Chromebooks, do you have like a separate number, like that weird number key thing to the right? You don't? That sucks. That thing is helpful. That thing is very helpful. Anyway, check this out now. I'm going to go to L2. I'm going to flip this over. I'm going to quickly type in Monday. 44, 46, 38, 40, 38, 37, 31, 32, 37, 41, 32, 44, 47, 34, 31, 40, 41, 32, 36, 31, 32, 39, 31, 41. There we go. Hopefully that was correct. People are sometimes amazed, like, how does he type it in so fast? I don't know. How do you guys text so fast? Weirdos. Anyway, check this out. If I want to look at the histogram, but I want to look at L2. Now, I didn't really spend time talking about this, but you'd have to change that to an L2. On your graphing calculator, the easiest way to change that to an L2, some of you already know about this. Look what's written in yellow above your 1, 2, 3, 4, 5, 6. Look what's written in yellow. So if I wanted to change that to an L2, I would change it up by hitting second 2. Now let me zoom 9 it. Ooh. Ooh, interesting. That is interesting. Now, hold on, let me do that again. Let me write some stuff down on the board. So on Friday, X bar was 42.28 and S was 4.43. And I'm just going to scroll down. I'm not going to write down the entire 5-number summary. Instead, I'm going to say the median was 43 and the IQR 5, 6, 7. Cool. And I saw that if I looked at the graph, which, by the way, let me go back to Friday real quick. If I go back to Friday real quick, zoom 9 it, I would say that this is symmetric. Honestly, the best I could say is that this is symmetric. It doesn't look perfect, but it's pretty darn close. It's pretty darn close to symmetric. So the best way of describing the center and the spread would be X bar and standard deviation. But now check this out. On your calculators, when you go to 1var stat, it takes you to that weird screen. Is that correct? Not a weird screen, but it takes you to a screen where you have to make a selection and then you calculate it. I'm hoping. Okay, a few of you are nodding yes. You would have to tell 1var stat which list to perform the calculation with. So if I hit second 2 again, now it will calculate my 1var stats using L2. And look what happened. Monday. Ooh, interesting. Come on. There we go. Good. S, 5.02. Let me scroll down a little bit. My median, 37. My IQR, what is that? Oh, crikey. That's 9. Ooh. Now this is something interesting. This is L2. Going back to L2. Again, I'm just doing a bunch of the legwork to kind of see what this thing looks like. Here's L2. Monday's tests. I mean, definitely I would say that this thing has more skewed right tendencies. If I covered the top half of that, let's just pretend the top half of this bar didn't exist. How would you describe the distribution if this top bar right here didn't exist? Like, let's say I lopped it off with a chainsaw. What would that look like to you? It wouldn't look like anything, Mr. Markey. It would look symmetric, but like when I add that bar back in, all of a sudden, what does it look like? Yeah, now it looks skewed right. Oh my gosh. With the exception of this little peak in the middle. Something's going on here. Something's going on here. Let me go back to the questions. So create a graphical display comparing the two distributions of scores. All right. Now it does say create a graphical display showing the changes. We'll deal with that in a minute. So I did that with the 2 histograms. You could look at box and whisker plots if you wanted to. Write a few sentences about the scores reported on Friday and Monday. Well, I mean, I could say on Friday, definitely they scored higher. Friday scores were symmetric. They were more consistent because of the standard deviation. You could even, I mean, you wouldn't use median and IQR for a symmetric distribution, but even if you did, that spread is still smaller than the Monday one. On Monday, scores dropped by almost 5 points. And the standard deviation grew, meaning less consistency between scores. Why would this happen in real life? Give me an explanation as to why something like that would happen for people testing. They took a vocab test on Friday, and then when they returned on Monday, they were retested. Why would they score so worse? You know why, high school students. Why? But you studied for it on Friday. But it was only 3 days. I know why, though. It's not so much that they would forget about it, because if you study something, it's hard to just completely forget everything. I would personally think that these students would cram the night before and just remember enough to get by on that Friday test. Oh, you students, don't do that. Why would you forget it? Don't forget it. Don't shake your shoulder. Anyway, shut up. Let's see. So writing a few sentences, I just talked about that. That would be acceptable. Now, it does say create a graphical display showing the distribution of the changes in student score. Now, this is something that I realize now. I'm like, if you wanted to do part C, if you wanted to see the changes, then perhaps you'd need a third column of, 42 minus 36 and 44 minus 44 and 45 minus 46 and stuff like that. And I'm realizing now, I'm like, I could have shown you something so easy. I could have shown you something so easy to get that done. I would, again, put forth your best effort on those problems. I mean, I haven't looked at them yet, but I would be very lenient on C and D. Personally, I'm just saying for myself. When I'm looking at them, I'm going to be pretty lenient only because I didn't show you something very simple. And that's on me. Here's the very simple thing. And this is a skill that I think is going to be helpful for when you're trying to manipulate data. Check this out. Friday, Monday, and I'd like to put the differences there. I don't know if you know how to do this, but I'm going to show you. If you go up to L3 and highlight L3, you could do L1 minus L2. And as long as you type that in above the column and then hit enter, it calculates all those differences for you, which is super nice. And I do apologize for not showing you that sooner, but it's something that is incredibly helpful. So like I said, for that particular problem, I'm going to be again, the homeworks are based on completion. It's just for you to get practice. No harm, no foul. So now if I wanted to create a distribution of the differences, I'd be typing in L3. Let me zoom 9 it. Haha, there we go. Like a big middle finger. Now, these are the differences. Friday minus Monday. Clearly, Friday's average is greater than that of Monday's average. Yeah. Tell me in a sentence, what do these scores represent? Tell me in one sentence what these scores that I just circled represent in real life. Ooh. Ooh. What types of numbers are these? They're negative numbers. What do they represent in real life for this problem? When they got a higher score on Monday. Just as a side note, there were a few students who did improve. Good for them. Obviously, some of them might be right on 0. I don't know. But you can definitely say that the majority of students definitely scored worse. If I had to describe the shape of this distribution, I'd say it's kind of borderline symmetric, skewed right. But if you had to make a call, I'd say, it's mostly symmetric. It's mostly symmetric is what this thing does. It's not perfect, but It's the best that you can do. I'm probably going to say this word like a million times over throughout this school year, but the word is context. Context, context, context. A lot of the time, when you get to higher level math, there is not a lot of context when it comes to trigonometry or calculus or things of that nature. They try to put context into them with trigonometry. It's like, oh, here's the size of your trunk, and you have to figure out, oh, I'm gonna go buy a bunch of watermelons. How many watermelons can I fit inside the volume of my trunk? And like that's like a calculus problem. But like, who the heck is stuffing watermelons into the back of their trunk? When in reality, statistics has many more real-world applications. Anyway, let's take a look at number 28 real quick. 28. Now I said for number 28, I put a star next to it. I said I'd be okay if you bombed it because it wasn't something that we had spent a ton of time on. Zoom back out. There we go. Is birth order related to your choice of major? Nice. I'm the youngest in my family. I'm the youngest. I have 3 older sisters. Feel bad for me. I see you shaking your head. Anyway, a statistics professor at a large university polls the students to find out what their majors were and what position they held in the family birth order. The results are summarized in the table. So birth order, first, second, third, or after. I would be the or after. And then math, science, agricultural, humanities, and other. Oldest or only child. Okay, cool. So if it is an only child, then yeah, that's probably why these numbers are a bit inflated, because obviously if you're an only child, you clearly are just the oldest and there's nothing to do about it. What percent of these students are oldest or only children? So what percent of these students are the oldest or only children, meaning those two numbers divided by each other? I don't know what the decimal is, but it's whatever the decimal is or the percentage that you could turn it into. That's 113 over 223. Those are very straightforward kind of question. What percent of humanities majors are oldest children? Now that is a very specific question. For that question, what percent of humanities majors, meaning only looking at the humanities majors, only looking at their particular set of information for part B. What is the probability that you're the oldest given that you are a humanities major? Now, I introduced that concept of given last time. We didn't spend a ton of time on it. I wasn't able to really finish what I wanted to do with it. We'll do that today, but that's what we got. Old given hum. So that'd be 15 out of 43, which again, I would calculate the percentage. I would round it to roughly 3 decimal places, 2 or 3 decimal places. It is in your best interest to change it to a decimal or a percentage. I would rather you not leave it as a fraction, because if you left it as a fraction, it is much more difficult to compare from one decimal to the next. Now check this out. Look at part C. What percent of the oldest are humanities majors? Look, they switched it up. Given that you're old, given that you're the oldest, given that you're only looking at the oldest children, of the oldest children, what percentage of them are humanities majors? So now you're only looking at that column, which means the calculation would be 15 out of 113. Love it. And then part D, what percent of the students are oldest children majoring in humanities? Now that's a different question. Part B was oldest given humanities. Part C was humanities given oldest. But part D is saying humanities and oldest. It's a completely different question. That would be 15 out of 223. I love the wording of these questions. You probably hate the wordings of these questions. But that's why I said I'd be okay if you bombed that one, because we didn't actually talk about it. I'm going to go into more detail with people dying on the Titanic again. But we'll deal with it. Ha, 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 ha. Now, if you have any additional questions in regards to this, make sure that you email me. I am going to have a lot of time tomorrow to catch up on stuff because they're doing the PSAT, but I don't have a class. I'm going to be wandering the hallways for some reason. How many kids are in 10th grade? How many kids are in like each grade level? 250? All right, I'm just trying to imagine what the school would look like with just a quarter of its population in there. That's really messed up. Anywho, here's what I need. Obviously, whatever papers that you just had, there's yours to keep, obviously, because I wanted everything submitted through Google Classroom. There's too many Google acronyms. Anyway, in the meantime, I'm going to need, if you do not already have them out, I'm going to need those notebooks out and open. Zoom. I want to recopy a chart. So I called it this last time, but I'm going to call it this again. I labeled them as like two-way tables or contingency tables. I'm just going to very quickly give it a title of that to kind of wrap that up, hopefully. Ba-boom. Now, I want to give you a definition first. I want to give you a definition, and then I want to apply that definition to the table that we have. Bullet point. Variables are said to be independent if the conditional distribution of one variable is the same for each category. I'll leave that there for a moment. Now notice I put independent, I underlined it just because that's the definition that I'm referring to. Variables are said to be independent if the conditional distribution of one variable is the same for each category. Now, notice I put the word same in parentheses because they don't have to be exactly the same. If the conditional distribution for one variable is 41% or whatever it ends up being, and the next one's 42%, they're not the same number, but they are approximately close, which is why I would say same in parentheses. Let me recopy the table that I gave you last time about people dying. You guys can recopy this as well. I'm going to need these numbers: 203, 118, 178, 212, 122, 167, 528, 673. I'm not going to give it all of the information in the world, but this was the Titanic information. Alive, dead. Cool. Now here's my question. I'll ask a few questions here. Come on, you. There we go. First of all, being on the Titanic, what is the probability that someone is alive? Well, if I'm going to figure out whether or not someone is alive on the Titanic or from being on the Titanic, first, let's figure this junk out. I'm going to need a couple of numbers. So first of all, if I add that across, I get 711. Probably did this last time. I'm just going to do it again. 1490 dead. 2201 total. Zooming in. The probability that someone is alive, we talked about this last time, going into more detail. 711 out of 2201, which I would have to give an approximate number here. 0.323. Now, I'm going to give it to you as decimals today just because I want to be weird about that. But typically, when you're giving a probability, you're going to give it as a decimal or as a percentage. Please keep that in mind. But now, I'm trying to figure out whether or not the two variables of your mortality status, which is alive or dead, and what do they call it? Whatever class you were in on the Titanic. The two variables in question are class and mortality status. Those are the two variables. That's why they call this a two-way table. It's displaying two variables. Variables are said to be independent if the conditional distribution, conditional meaning the word given, of one variable is the same for each category. Now, I just got the probability that someone was alive. Good for me. But there's no condition on it. There would be a condition, a conditional probability, if I have the word given in the middle. So, what is the probability that someone is alive given they were in first class? Now, again, that vertical line means the word given. Be careful with that. So, given they were in first class, given that you were only looking at first class people, according to this, there were 325 people in first class. 325 people in first class. The probability that someone is alive, given that they were in first class, that'd be 203 over 325. 203 over 325. Whenever you have the word given, you have to look specifically at that category. Given first class. Okay, I'm only looking at first class. Of the first class people. Okay, only looking at first class. If I did that, that would be approximately 0.625 if I had to round it. Usually I like to go 2 or 3 decimal places. Now, I'm going to change it up again. What is the probability that you are alive given you were in second class? Well, second class had 285 people. The probability that someone was alive, given you were only looking at the second class people, 118 out of 285, which is approximately 0.414. Now, technically, I do have enough information right now to kind of make a conclusion about my definition above, but first I want to do a couple other calculations. I am also going to calculate, and you can kind of jump ahead of me if you already know how to do these. Test yourself to see if you can get it. But I'm also going to calculate the probability that someone was alive given third class, and the probability that someone was alive given crew. I'm going to do those calculations as well. Just typing these in. This is 706 people in third class. and there were 885 in the crew. I haven't actually checked. Oh, okay, yeah, no one's. Yeah, I like to check the live stream. I forgot to open it up over here. Good. So, I gave you a moment to do that. I'm going to do it myself now. 178 at a 706. Clearly, you can hopefully see that pattern there. 178 over 706. I'm going to zoom in. It's a little bit better. 178 divided by 706. I'd write down approximately 0.252. And being in the crew, given that you're in the crew and that you're alive, that's 212 out of 885, which is approximately I'm going to round it to 240. That's what it rounds to. So now I'm going to go back to that definition. I'm just going to read the definition and look at these numbers. More specifically, I'm going to be looking at those numbers, those four calculations. Variables are said to be independent if the conditional distribution, this right here is the conditional distribution. And let me actually write that here. Conditional, I wrote on my table, distribution. The two variables in question are mortality status and class. Variables are said to be independent if the conditional distribution of one variable, in this case being alive, the mortality status, is the same for each category, the category in this case being what class you were in. Clearly, these numbers are not the same. When I said if I were to say they were the same, they would have to be a lot closer. When I say a lot closer, I mean within 1 or 2 percentage points. At most, maybe I'd go 3, but they would have to be a lot closer than this. A lot closer. Conclusion. I cannot say that they are dependent. I cannot say that they are dependent now. The best that I can say is the following. The variables of class and, for the lack of a better term, mortality status appear to be not independent. Based on the above calculations. There we go. Let's talk about that. Again, the variables, class and mortality status, are the ones that I've been talking about this entire time. Notice my fluffy language, appear to be not independent. And again, fluffy language based on the above calculations. I based it upon the numbers that I were given, and I did the conditional distribution. You are not allowed to say that they are dependent. You are not allowed to say that they're dependent. You have to have much more evidence to show that two variables are dependent on each other. For example, a deck of cards. If I were to pull out the first card, there's a certain probability for the first card. But if I don't put it back, if I set it aside, now I only have 51 cards in my hand. All of a sudden, that second probability is dependent on that first card or whatever that first card was. That's a completely different situation. But for this definition, the best we can say is that the two variables in question are not independent. That's the best we can do. Unfortunately, but them's the breaks to an extent. Okay. I need to give you some notation. You may or may not have seen this in your textbook. You may or may not have seen this in your textbook, but I need you to see this notation that I'm about to give you. Oh no, my clip. It's dead to me. Anywho, so let's talk a little bit about notation. Notation. Here, clip. There you go. Good. So 3 categories here: type, sample, population. You may or may not have read this in the textbook. I can't recall exactly where this is located, but I wanted to give it to you now just so we are all on the same page. I've given you a few of these before, but I want to make sure that we're on the same page. If you're talking about mean, if you're talking about average, well, it depends on whether or not you're talking about the average of a sample or the average of a population. If you were talking about the average of a sample, then we always use X bar. Now, this is going to come into play later on in the school year. Later on in the school year, if you are not using the proper notation when describing a sample or a population, points will be lost. An AP grader, that is exactly what they look for. They look to make sure that you are using the correct notation. That is X bar. For a population, we use that symbol. Do you remember what I called it before? What number is it? Which Pokemon is it? It's 151. Thank you. Gold star. You don't want to? Okay, fine. No gold star. But yeah, this is mu. It is a Greek letter. Just, you have to know which to use. If you're talking standard deviation, if you're talking a sample, we use the letter S. We use the letter S for standard deviation. You've seen that in your calculator. But if you're dealing with a population, you use that symbol. Did I tell you what that one was called? I don't know if I did. Say again? Yes. Did you know there are actually 2 different sigmas? Oh, it's not an E. It's like a weird looking S thing. Here, hold on. These are Greek letters, just so you guys are aware. These are Greek letters. This is the lowercase letter sigma. Sigma can be written like that, lowercase, or sigma could be written like that, uppercase. You guys know pi, right? Of course you know pi. Did you know that pi was actually, you probably knew it was a Greek letter, but did you know it was the lowercase form? No, here's the uppercase form. That's the uppercase form of pi. I'm not even kidding. It just is. Yeah. Greek letters, both capital and lowercase, mean different things depending on what you're doing in the realm of mathematics. So sigma, capital sigma, that weird S thing that you talked about, do you remember what it means? Or what it tells you to do? Say again? Yes. Capital sigma means add everything up, the sum of. That's what it really means, the sum of. Lowercase sigma, in our context, is going to mean population standard deviation. That's what it's going to mean, population standard deviation. Fun fact, capital pi actually means, you know how like sigma means add them all up? Capital pi means multiply them all together. Weird, I know. You guys know about hurricanes, right? You know what a hurricane is, right? Okay, good. You know how they name them? Every year they name them. They have a list of predetermined names that they choose from. 1 letter for each of the alphabet. Except they skip a couple. What happens when they run out of letters? They use Greek letters. Hurricane Alpha, Hurricane Beta. You didn't know that? That happened this year. Hold on. Yeah. This is so weird. 2020 Hurricanes. Oh, look, I've already looked it up. If you go through the list, right, wait, I passed it. There it is. If you go through the list, Hurricane Teddy, Vicky, oh look, Beta, Wilfred, Alpha, Gamma, Delta, Epsilon, Zeta. They go to Greek letters. That's their default. So currently, right now, Hurricane Zeta is going to go over the United States, but it's probably not going to be a hurricane by the time it does that. I don't know. Know your math history. It's funny when they get to Hurricane Epsilon, because Epsilon means infinitesimally small amount. Hurricane Epsilon. Anyway, this is Sigma. Sigma. Correlation. Now, this is for later in the school year. This is actually for when we get to the next unit, I believe. There's one more major chapter that we have to cover. I'm going to give you a little bit of information on that today before we leave. But the next unit is going to start with correlation. And in correlation, we deal with this thing called the correlation coefficient. And the correlation coefficient is literally the letter R. It's just the letter R. So R is going to be a variable that is going to be introduced to you later on in the school year. But that's only for a sample. That's for a sample. If you're dealing with a population, it's that symbol. That is called, well, that's actually another Greek letter. It's called rho, but RHO. You're probably used to like capital Greek letters in regards to like fraternities and sororities or some junk like that. You guys know about the fraternity lambda, lambda, lambda? Do you know about it? Yes, thank you. All right. Gold star. Anyway. There is also something known as the regression coefficient, which again, we're going to be doing that in the next chapter. You're going to be able to calculate a lot of the stuff on your calculator. It's called the regression coefficient. Maybe in Algebra 2 or some previous year of math, did you guys ever do linear regression? Maybe. I don't know. Scatter plots, finding a line of best fit. Okay. They didn't call it linear regression? Okay, well, that's what this is. Now, the regression coefficient is going to be used the letter B, but that's for a sample. For a population, they would use the word beta, which is the Greek letter, of course. And then finally, last one I'm going to give you here is the proportion. The proportion, if you're dealing with a sample, then the symbol that you're going to use for a proportion is this symbol right here. Now, what does that look like to you? Yes, it's the letter P, but what does it look like? Say again? A house? It's a small house. I wouldn't say it's a house. I would say it looks more like a hat. I'm not even kidding you. You're going to read this as P hat. You will, because that's what it is. Now, it's similar to X bar. Look at X bar. X bar has got a bar over the top. That's for a sample mean, but then the P hat with the little hat on the top, that is for a sample proportion. But then we have a population one. And it's that symbol right there. Do you know what that is? It's literally just the letter P. Here's how you pronounce it. Just so we're all on the same page. Your textbook does something similar, which is funny. Okay. I'm going to introduce something to you. Very briefly, I just want you to have this basic information before we move forward. Like I said, in regards to graphical displays, I am going to give you something in regards to graphical displays to do for me before the end of this week. I'm going to give you some chapters to read in the textbook over that week off, and maybe some videos as well to kind of help kind of move this thing along. When we come back that week of the 9th, it'll still be the schedule that we have right now. But the week that we come back the 16th, I'm either going to see you 2 times a day or 2 times a day. What a world. 2 times a week or 3 times a week. In that regard, I am going to be able to teach multiple lessons a week, finally. So I'm excited. I don't know about you. Let me introduce something to you before we leave here today. I need you to draw something. Look at that. That's wonderful. That is the normal distribution. That is called the normal distribution. We have seen it emerge in various samples. We have graphed sample data, and we've seen histograms take on that shape, kind of. But this is what they call the normal distribution. This is like the precise normal distribution. Have you guys ever seen a paranormal distribution? No? Hold on. If you've never seen a paranormal distribution, I don't really know what you're thinking of. This is a paranormal distribution. Just so, again, we're all on the same page. Anyway, back to this. Now, in the normal distribution, obviously this thing is symmetric and unimodal is what they call it. They call it unimodal, symmetric and unimodal. Unimodal meaning it only has one peak. If you have a distribution that is symmetric and unimodal, meaning that peak right in the middle, of course, then it is something that is obviously very close to what we call a normal distribution. A lot of real-life data graphs like this, graphs something very close to this, where right in the middle, right smack dab in the middle of that distribution is mu, or your mean, your average, your population average. Obviously, a lot of populations do end up looking like this. But what's nice about this is that at certain intervals, and you look at the intervals that I put up there, at certain intervals, we can model what this thing is supposed to look like using that mu right in the middle and standard deviation. Mu plus sigma is about right there. That's a sigma. I know it looks like a 6, but I'm trying to write sigma there. This is mu plus 2 sigma. I'll zoom in. Again, I know it looks like a 6, but I'm trying to make it look like that Greek letter sigma. And this is mu plus 3 sigma. Now, because this thing is symmetric, because of all of the wonderful properties that it has, you can copy that information onto the left side as well, except it is mu minus sigma, mu minus 2 sigma, and mu minus 3 sigma. This normal distribution is going to become incredibly important moving forward. And what's wonderful about it is this. By the way, my picture is so not symmetric right now, but it's supposed to be. It's supposed to be symmetric. What's wonderful about the normal distribution is that if you took a population mean and a population standard deviation, like let's say for like adult male height, for example, and you went +1 standard deviation and -1 standard deviation, you would capture 68% of the population. If you went +2 standard deviations and -2 standard deviations, you would capture 95% of the population. And if you went from +3 to -3, you would capture 99.7% of the population. Now, I'm going to go into more detail of this the next time we cover this lesson, but I wanted you to be able to see this as an intro. There is a certain name that goes along with it, but these numbers are pretty darn consistent the more normal a distribution is. Pay attention to Google Classroom. The assignments will be in there. I don't know when I'll see you next. Yay!